In this video, I'd like to continue talking about constructing sinusoidal functions. And for this example problem, we will be given information about our sinusoidal function. For instance, that it has a maximum point at 0, 5 and a minimum point at 2 pi negative 5. And we will need to find a formula for this function. Now, there are many strategies to approach this, but it might be easiest to first start by actually plotting these points and creating a picture, though we will also need the general sinusoidal equation, namely that y is equal to a multiplied by the sine or the cosine of, let's go with the cosine of bx plus c plus d, and each of these parameters, a, b, c, and d, will tell us information about the transformations of this curve relative to its parent function. And we will also need to determine whether or not we should use the sine or the cosine, since one is generally going to be easier than the other, though we could actually use either, since sine and cosine are really just shifted versions of each other. So let's start by actually plotting this curve. We have a maximum point at 0, 5. So let's say that's our maximum right there. And it has a minimum point at 2 pi negative 5. And we'll need a scale for our y-axis. Let's say we just go with pi over 2 for each of these. So this would be pi. This is at 2 pi. And this is 3 pi. So 4 pi would be right here. And we can plot our minimum point. This is at 2 pi and negative 5, so somewhere right about here. And if we want, we can even use symmetry to find a third point that we weren't given, since we know that the sinusoidal functions intersect their midline exactly in the middle of maximum and minimum points. So the midline would have a y value right in the middle of these 2 points, and if we average negative 5 and 5, the y value in the middle of that is just 0. And if we average their x values to find the middle of 0 and 2 pi, we would find that pi is right in the middle of that. So this point right here will intersect the midline of our sinusoidal function. So it looks like our curve is something like that, though that's not drawn very accurately. And from here we can determine whether or not to use the sine or the cosine. And to do that, just remember that the sine function when x is equal to 0 goes through its midline, and then the parent function will come up to a maximum, go back through the midline, then the minimum, and then back to the midline again for one period. But the key takeaway is that the sine goes through the origin for its parent function, or its midline, whereas the cosine goes through its maximum value when x is equal to 0, then comes down to its midline, and then to its minimum point. So in this case, we look at when x is equal to 0, and we can see that we're going through a maximum point. So the curve that makes the most sense in this case is to use the cosine function. Though, like I mentioned, if we want, we can use the sine function and then just shift it with this value of c here. Now at this point, we can look at our general sinusoidal equation and try to figure out what a, b, c, and d are. Since a deals with the amplitude of the function, we can see that the amplitude, the distance from the midline, which by the way is just y is equal to 0, since this point right here intersects the midline. The amplitude is just the distance from that midline to either a maximum point or to a minimum point. But in both cases, a is equal to 5, or the amplitude is equal to 5. And we just need to remember that the amplitude is equal to the absolute value of a. And in this case, we know that the amplitude is 5, so the absolute value of a is equal to 5, and we will just need to determine if we have any type of reflection here. And what we can see is that compared to the parent function for the cosine, that goes through its maximum value when x is 0, and then comes down to the midline, and then to its minimum value. It looks like there is no reflection here. So a is actually a positive number, and we can determine that a would just be 5. Now, d affects the vertical shifting, and in this case, the midline is still 0, which is the midline of our parent function. So it doesn't look like we shifted this up or down at all, and we can conclude that d is equal to 0. Same for our c value. Since we aren't shifting this left or right, when x is equal to 0, we do get a maximum point, just like the parent function for the cosine. We can also assume that c is 0. And at this point, we just need to determine what b is equal to. And to do that, we need to figure out the period of the function. Since the equation involving the period in b is simply that the period is 2 pi over the absolute value of b. So if we can figure out the period, we can figure out what b is equal to. And for the period, there are many different approaches, but if we plot a few more points, we can figure it out visually, since it looks like every pi radians, we get another key point. So if we go another pi radians over, it'll intersect at the midline again. And if we go another pi radians over, it will reach another maximum value. So it looks like if we construct this curve here, that it goes through one unique oscillation in 4 pi radians. So our period here is simply equal to 4 pi. So we have 4 pi is equal to 2 pi over the absolute value of b. If we solve this, we can multiply each side by the absolute value of b and divide each side by 4 pi. So we get 2 pi over 4 pi. The pi's cancel. We get 2 over 4, which simplifies to a half. And we can determine if b is positive or negative by looking to see if we have any type of reflection. But we already considered that. We don't have a reflection here. This generally follows the same shape as our parent function, though it is stretched both vertically and horizontally, but we don't have any type of reflection. The parent function generally follows the same curve, but like I said, we stretched it vertically and we stretched it horizontally. So we don't have reflections, meaning that we can assume b is a positive number, so b is simply equal to 1/2. And there are other ways to consider finding the period without having to actually draw out these points. One approach is that from a maximum point to a minimum point, that would cover half the period. So if we find that horizontal distance, which is just 2 pi, then we can double that to find the entire period. That is one other approach, but there are others as well. So from here, we can put all of our information together to figure out our function. We know a is 5. We know we have the cosine of 1/2 x plus 0, and then we have plus 0 on the outside. So this right here looks to be our final answer. And of course, we can check this by using a graphing calculator to plot our function and then making sure that both of these points are actually on that curve.